Hi guys. In the previous video, we saw how to create the edk-ii library destructor. Okay. So in this today's video, we'll see how to create the PI driver. Okay. So the PI driver is similar to the library constructor, but instead of the naming constructor or a destructor, we had to create the keyword as an entry point. Okay, so let's see how to create the PI driver in this today's video. So let me open the same source. Okay, so for every driver, either it might be a library or a driver, we need to have the C file and as well as the INF file. Okay, so now I will go to emulator package. Okay, so directly under the emulator package, I'm going to create a folder called um, sample driver PEI. Okay. So now within that, I'm going to create one C file and one INF file. Okay. So for this INF file, it needs an header, so I can copy from the different file. Okay. So this is the header section, right? So now here, let me rename this to sample driver PI, and then I can remove this copyright of one of it, and then I can change the copyright here. Okay. So now either it might be a library or a driver, it needs to have the define section, right? So now let's create the define section. Okay, so in this define section, so let me go back to the spec. So here we have this define section, right? It will have the INF version similar to the library name, library, and we used to have the base name, which is to identify by the map file, and we used to have the file GUID, and here the module type as a PIM because we are going to create the PI driver, and the version of that INF file and the entry point. Okay, so let me copy this. Okay, so now first thing is our driver name, which is sample driver PEI, and then we should create the GUID, Control Shift P, insert GUID, select the first one and change it to uppercase. Okay, and then the entry point. So entry point is a function which is going to, whenever this driver is going to be executed, there should be some function should be called, right? So now let's say let's keep the function name as same PI sample initialize. Okay. So now so this is done with the define section. So then we need to have the source section. Okay. So in the sources, so we used to keep this INF file include which and all the C files. Okay, so in this case, sample driver PI.c file. Okay, so I'm going to include only one C file. And then we used to have the package section. Okay, so in this we used to provide the DEC files. So the DEC files used to link the include folders. Okay, so in this case, md package slash md package.dec, emulator package, emulator package.dec, and then we need to provide the library classes. Okay, so what are all the different libraries this driver is dependent on? Okay, library classes, and then so first thing what I'm going to provide is PIM entry point. Okay, so why we need to provide this PIM entry point? Because this is a PI driver. So when this driver is getting called, the PIM entry point itself is going to call the entry point of this driver. That is the reason we have to provide the PIM entry point here. And then in this driver, I'm going to use some debug library. So debug lib. This is done with the INF file. Okay, but there is one more thing. If I come to this dependencies of the PIM, right? So we can alter the execution of this INF file. Okay, so by providing the depex. Okay, so this depex is nothing but a dependency. Okay, so when this depex is used, assume you will have the two PI drivers, and this PI driver is dependent on some other driver. Until the driver get loaded, you cannot dispatch it. Okay, so during that time, you can use its PPIs or the GUIDs, and you can mention that a GUID here. And that time, after that GUID get installed, this driver will get loaded. Okay, so in this case, we can dispatch our PI driver immediately. So for that, we can simply specify as a true. Okay, so you can go through this spec. I will attach all the links in the description. Okay, so now I'm going to provide the depex as true. So this is what it is needed to create the PI driver. Okay, so now this is the API name. So now we have to add the entries in the C file. Okay, so let me copy the header files. Okay, so I will simply say sample driver PI, and then I will use this 2023, or maybe I can get from this NFL itself. Okay, so now let's include the required header files. We need library slash debug lib, and let's include the basic functionalities like library slash baselib.h, and then base.h. Okay, so now we have to create the API. Okay, so now here we got the API name, so I will copy this. Okay, so here let me make some alignments. Here it should be star star. So now it does not know what is the definition of this EFI PEI file handle. So let's see where this is coming from. This is coming from this PEICIS.h. Okay, so this file is included in another file. Let's see where that file got included. So it got included in the PIPA.h. Okay, so let's include that file as well. Hash include PIPA.h. Okay, so now you can see the required errors are gone. Okay, so let me make some alignments. Okay, so now it used to return the status. Okay, so let's return EFI underscore success. Okay, so now so since this in this INF file we have added the debug lib, we can able to call the debug libraries here. Okay, so now I will say debug underscore info, which is an informative, and then let me add a keyword like BIOS and suppose say PEI, and then I will use percentage %a entry, or maybe suppose say called /n, and then I can say underscore underscore function underscore underscore. Yeah. Okay, so we created a driver So this driver is used to print some message, okay, and then it will return success. Okay, so let's create some variables as well, right? So uint 31, variable 2, okay, and then here I will say variable 1 is equal to 10, variable 2 is equal to suppose say 40, and then here I will say sum is equal to percentage d, and then here I wish to pass variable 1 plus variable 2. So now what our driver is going to do? So it is to create two variables which is assigned with 10 and 50, and then it will try to print our driver get called, and then it used to print the sum of these two numbers which we have given. Okay, so now this INF file we have to link in the DSC file. Okay, so I will open the emulator package.dsc. Okay, so here within this I will search for components. Okay, so we have to keep our EFI drivers under the component section. If it is a libraries, we used to keep under library classes. If it is a driver, then we used to keep under components. Okay, so let me keep this under the PI module section. Maybe suppose somewhere I can keep it here. Okay, so I have to provide the path for that INF file, emulator package slash sample PI driver slash sample PI driver dot INF. Okay, so now I will go to build folder. Before going to build folder, right? So let me open the command prompt. I will do the edk setup. Okay, I will do the split screen. Okay, so I will go to this build folder, emulator IA32, VS19, IA32, emulator package. So this is where we created our sample PI driver, right? So now I will do the build. Let's wait for a moment. Okay, looks like it is passed. Let's wait. Yeah, so here we can see sample driver PI folder got created. Okay, so let's see what we have in that. So build I32 emulator package, sample PI driver, debug, autogen. So in the autogen, it used to take some preprocessor directives so that we can ignore for now. But what we have to concentrate is this process module entry point list. Okay, so this process module entry point is called by that PIM entry point, and then our entry point function, which is this PI sample initialize function, will get called. Okay, so now in the H file, it used to define some declaration. Okay, so now if I go back to the map file, so here we can see our map file got created. It used to have the code and the data section. Okay, so within this, you can see what and all the functions our driver, which is the sample driver PI, is going to use all the functions, and it is linkers are going to be shown here. Okay, so where this information it is coming from? It is coming from the compiler. Okay, so how the compiler is generating this map file? So I will go to browser, and then I will search for MSVC Microsoft Visual Compiler underscore map. Okay, So whenever we are compiling the source, if you used to provide the underscore map, so then it used to create the map file, which used to have the module name, timestamp, and its linker. So if you look at the format, we have the module name, timestamp, and the required files, objects. Okay. So now let's go back to this i32 folder and let's run our WinHost. I will redirect to boot.log as always. It's booted to UEFI shell. Okay. So I will close the terminal. I will open the boot.log. Okay. So we have added a keyword BIOS. Not this, not this. Yeah, here. Not even this. Okay. So as you can see, we have added this message. Let me see this one. Okay. So here you can see this message did not got printed. But if I go back to the build folder, emulator package, and then sample driver PI, and then sample PI driver output, here you can see we got our EFI binary, which is having a size of 28 KB. Okay. So now even though we have the EFI binary generated, it didn't got builded. Okay. Meaning it didn't got included in our firmware binary. Okay. So let me see. Yeah. So here also we have this sample driver PA. Okay. So now to include, so this file is not present under, if I go back to FV folder. Okay. So we have this FV recovery.fd, right? So that EFI binary should be present in this FD file. And so since that EFI binary is not present in this FD file, due to which it is not getting dispatched. So how we can confirm whether the driver got included in this FD file or not? We can use some FMMT tool. Let me see if I have that handy. FMMT-V. Yes, we have FMMT-V, and then let me copy this path. Okay, so build IO32 debug SV. Okay, so here we can see. Let me redirect this to some file. Suppose say temp.log. Okay, so now I'll go back to the editor and I will open that temp.log. Okay, so this temp.log is having a firmware ID, which is this firmware volume 0, and its firmware volume GUID, and its attributes, and what is the size of the total firmware volume, and how much free space available in that firmware volume. And these are the binaries it contains. Okay. So if I go back to my INF file, so this is my file GUID. If I search for my file GUID in the temp.logs, it does not exist because I haven't included. Okay. So now to include, what we have to do. Okay. So here as I included in the DSC file, I had to include the same entry in the FDF, firmware descriptor file. Okay. So now here we have our FV recovery. Okay, so this is our a priori. So a priori, in the later session I'm going to discuss. So this is our PA sections, right? So maybe let me dispatch maybe after this boot mode PA, right? So let me dispatch my driver. So here, directly instead of directly providing the path for our INF file, we have to specify what is the file format. So in this case, my file format is a INF and the path for that INF file. Okay. So now I just added this entry in the FDF file. Now let me build it. Let's wait for a moment. Looks like it is including now. It is generating the firmware recovery. Okay, so now let's try to look at into the fvrecovery.fd file. Okay, so same thing. I'm going to redirect to some temp.log. So the command got successful. So now I will go to this temp.log, and if I look for that same GUID, I can see the entry, and here it says sample driver PI, and it is going to be loaded after this boot mode PI. Okay, so now let's run it. Pin host. Okay, so it got booted to UEFI shell. Let's close this and let me open the boot.log. And here you can see after this boot mode PI, our PIM, which is our, you can see the file GUID, right? So the file GUID is coming from the sample driver PI, and it got loaded. And once it loaded, it is dispatching. Here you can see, and it is dispatched at this address. And here you can see BIOS PIM, our function name get called, and we have provided two variables, right? So the sum it got printed here. Okay, so what we learned today? So we created the INF file and the C file for the PIM driver, and we linked this PIM driver in both DSC file as well as the FDF file. And then we looked into the firmware volume to check whether our driver got really been present in that particular firmware volume or not using the FMMT. So you can store this command. So it's a FMMT followed by -v for view, and then followed by the FD file name. Okay. And then we looked into our boot.log to confirm whether our driver got successfully dispatched or not. And then we went through the map file to understand about what and all the different sections within the map file. That's it for today. Thank you.